Hello, everybody, and welcome back to another episode of Godot Academy. Today, we're going to be doing a Godot coding challenge where we're going to make a tween visualizer. So, for those who are unfamiliar, tweening is a way to animate a property of some object. So, for example, you could change the speed of something or the position of something. And tweens come in a number of varieties. They come in these 11 different types. So, quadratic, cubic, linear. You can see most of them kind of look the same, but they all have their different characteristics. And most notably, elastic and bounce sort of go beyond their boundaries and come back. Or linear, you can see, is just a straight line. So it can be useful for just linearly interpolating something. You'll also notice they each have 4 different colors, with the exception of linear. They're just all stacked on top of each other. And those are the easing types. So we have the transition types, which are in the big letters here, and the easing types, which are the individual colors. And these are ways to control the tween. I'm not going to go into too much detail of the specifics of tweens. There's plenty of great documentation on the Godot wiki. But what we're going to try to do today is make a way to visualize this cheat sheet, which, by the way, the cheat sheet is available. There's a link in the Godot documentation. We're going to try to animate these graphs here so that way we can see them sort of in motion as opposed to just as a static image. So before we hop into the actual engine, though, step 1 is let's sort of cover with a drawing what we want to make. So not only are we going to be going over tweening, but we're also going to be going over a little bit of user interface and even canvas drawing. But those aren't the most critical parts. What's going to be the most important is going over these tweens and how we can get them to sort of draw the lines we're interested in. So let's start with our user interface. We're going to try to keep it as simple as possible. We'll just do 3 sections. The first section, let me make this bigger. The first section on the top will be tween controls, and so that'll be, for example, tween transition type, which will be we call it an option or a combo box depending on what engine you're used to. And that is just going to be a box that, say, has a drop down, and you'll be able to pick from the options. For example, linear would be one of the options, or we would have all of the available options in that cheat sheet. So quaternion, quadratic, cubic, linear, elastic, bounce, etc. And then the next thing we'll do is have 4 checkboxes, 3 and 4. And each of these checkboxes will be for one of the easing types. So we can have all 4 of them checked and draw all 4 lines, or we can only have 1 checked and only draw one of the lines. But either way, we want a way to let the user check on these, and they'll be, ease in and ease in, out, all of the assorted types that are there. This main window will be where we actually render the tweens themselves. We'll get back to that in a second. But because I want these to be animated, at the bottom we'll have a playback. And to animate the playback of these, we'll also use a tween, since we're on the subject of tweens. And so we'll have a combo box for which tween to use. And let's just say this is linear, just for some dummy text. And we'll also have a combo box of which easing type to use. And we'll say it just starts with ease in. Okay, so we sort of have our user interface controls. Those are not quite as important, and I wouldn't focus too much on them, but they're just very basic layout and very basic controls. But the most important part is this section here in the middle, and we're just basically going to draw the assorted tween graphs, the tween visualizations for whatever setup has been given. So to do that, we'll probably want something like a little bit of margin space, just to give us some room, so that way we're not too close to these boundaries here. So we might be drawing into a box that looks like this. And then we would probably just designate some part in the bottom left corner is 0, some part in the top right corner is whatever 100% would be. And we would wind up with a bunch of visualizations that would, sort of match whatever we're seeing in the cheat sheet, which is just the actual tween values at various time steps for each easing at some transition type. So bit of a long-winded way to go, and we're going to move pretty quick with this so we don't take all day, but we're going to be targeting something that looks a bit like this. So I've already gone ahead and created a dummy project. Right now it's just everything that comes by default, and we're going to work on first this center spot, and to do that we're going to be using all user interface nodes. So we just have a basic control, and the control allows us to draw shapes within it by using a update and draw function pair. And just to get started, we have our control, so let's get something drawing. So we'll go here and attach a script, and for today we're going to do everything in C#. So for those of you who are looking for more C# examples, this is going to be a perfect way to go. And we'll just save everything in this root folder because I'm not terribly concerned about organization right now. So we will create our new control. In fact, let's rename it to Tween Visualizer. There we go. We'll attach the script, Tween Visualizer, and create. So for those of you who are interested in using the C# version for programming Godot, I am using the mono build, and I do have a video that covers how to set this up. I've already got it set up, and I've already got it working with my IDE of choice, which is JetBrains Writer. All of this will work on Visual Studio Code, but I'm going to be using JetBrains Writer for this. So I've created our first script for the Tween Visualizer, and we're ready to get started. So we were going over that first we need to be able to, we want to be able to visualize the various transition types. So we'll be able to, I want to be able to pick one of these, and want to be able to visualize each of these easing types. So we'll also want to pick one of these. So to do that, we'll first export two variables for this class. One will be the transition type, and one will be the easing type. And to do that in C#, we can just do export. That says we want to export something, make it public, and it'll be a tween.transition type, which is the enumeration of the various transition types that a tween can have. We'll just call it transition type and give it a getter and setter. For those who are not familiar with the property pattern in C#, I recommend you go look it up. There's a million tutorials for it. But basically this allows us to expose this transition type as an export to the Godot engine. And we'll just make it default to maybe the exponential. We had linear in the example, but it doesn't really matter. So now we have the transition type. Let's also export a property, public tween.ease type. Ease type, same thing. We'll give it a get and a set. And we'll just start with, maybe ease in as the default. So very simple. And just to see this, we'll hit build. We'll let it build the solution. Might take a minute for the first time it's built. And now we can see that we have these two transition types, these two properties, transition type and easing type, that we can pick from in our script. So let's save our scene. So now we just have an empty scene that allows us to pick transition type and easing type. Now, to do all this, we're going to need a tween node to actually for us to tween. So let's just add a child here called tween. And in our script, we'll want to grab this. So let's make a private tween called tween. And when the node is ready to go and it's added to the tree, we can just set tween to equal get node. And it'll look for tween, since we have it named as tween. And we'll just make it, typecast it as a tween type, so that way everything's good to go. So now we have access to a tween. And that's pretty much it. So we have a tween and we have its configuration. Now when we run a tween, tweens basically can interpolate from a time step from 0 to, let's say, 100%. And as it interpolates from that time step, we can give it a easing function and, of course, the transition function to determine the value that it has. So if you think of this x-axis here, that's the time step. So this is at time t equals 0, and this would be time t equals 1 from 0 to 1. And it will output a y coordinate, and then we'll be drawing a dot at the x time step and the y output coordinate. So let's first set up our x coordinate. So our x is just going to be some floating point number that goes from 0 to, we can call it 100, we can call it 1. Let's just call it 100 just so that we can think of it as 100%. So let's export that as a variable that we can modify. We'll give it a property hint of a range. Since we want it to start at 0 and go to 100 and never really go outside that range, we'll just give it a property hint of range. And the way that the range works is you can give it the start, which is 0, the stop, which is 100, and you can even give it a step, but we'll let it be whatever step it comes out to. And we'll make it a public float, so we have a floating point number, and we'll call it progress. Time step, whatever, but progress is good enough for here. And we'll make it a property. When we get the property, so we'll set up a getter, we'll just return a hidden or a private, like a privately backed variable called progress. And let's make that right now. So we can go private float progress, and maybe we just start it at 0. And when we set the variable, we want to do two things. First is we want to set our progress. Oops, we don't need this. And let's do that. So we set our progress, which is the privately backed value. But we want to make sure that we don't go beyond our range, since it is possible for somebody to set it in that range. So we will just adjust it. So our adjusted equals, we'll start with making sure that it never goes over 100. So we'll do value and 100, since that's the max. But we also want to make sure the value never goes below 0. So we'll do math.max between the value and 0. So this will put it within the bounds of 0 and 100. Might be a better way to do it, but this is the way we've got it. And we'll set the adjusted. And whenever the progress updates, we'll want to tell the control to redraw. So the way to tell a CanvasItem, which is a node 2D or a control, is we can just call update, and that'll tell it to redraw itself. So now we have it. So whenever this property is modified, the progress will get a setter called, and it'll tell it to cap the value within some range, set the progress value, and then we'll tell it to update, which we'll just say draws a new frame. So we have a couple of things. We have the setup, we have a tween node that we can reuse, and we have a progress that sets us the value. So now we can use that tween to give it an x value, and it'll output our y value. So we have the x value, which is progress. We want to get a y value. To do that, let me check my notes. We'll do it pretty simply. First is we got to create our draw function, which is the one that gets called when update is called. That one is just public override draw. And we'll override the draw function much like how we're overriding the ready function. And there's no need for us to call the superclass draw function. But basically we want to convert our progress, which is from 0 to 100, into percentage. So we'll want to normalize it, and to do that we'll just divide it by 100. So our progress equals the progress value divided by 100. We could save this as like a constant, which would be the maximum value, but we're trying to go quickly. The next thing is we have our tween object. Whatever the tween happens to be doing, we want to make sure that it stops so it doesn't do anything. So we'll just do tween.stop. Then we want to call the tween's interpolate function. So interpolate is the way for it to control its output. There's a bunch of different interpolations that you can see here on the documentation. The one that we're interested in is interpolate property. They all do basically the same thing, but we want to interpolate the property, which takes a couple of parameters. First is what object to mess with. Next is what property to mess with, the start and end values, how long it should take, and then we also have transition type, easing type, and a delay. So using that as our baseline, oops, and we'll do stop all. So that'll stop any tweens that might be currently running. Hopefully we won't have any that are running, but we'll just make sure that everything's cleared. And then we'll call the tweens.interpolate property. And once again, it takes which object to mutate, which is just going to be this. It takes what property to mutate. We'll call it draw position. So we need to make a new property, which is the y value, which we'll call the draw position. And to do that, we'll just make a public float draw position, and we'll just start it off at 0. But basically, we want to be able to modify this draw position on ourselves. The next value or the next variable is the start. So we'll just say it starts at 0, which is the bottom. We'll go to 1, which we'll just say is the top. And the duration, we'll just say 1 second, because we're not really going to be waiting for the tween to run. We're just going to be going from some value 0 to some value 1. So the duration will set as 1. Next, we have the transition type. That one, we can just use our property here. So we called it transition type. So we'll just use that variable. Same with ease type. We have that set as a variable, so we'll use it. And then finally, we don't need a delay, so we don't actually need to give it. It's an optional argument. But basically, this will set up our function to say, mess with this draw position variable from 0 to 1. We'll give it a duration of 1. This just it matches the normalized progress value. And then we'll use the transition and easing type that we were given with the exports. And then finally, we can just tell the tween to go to that progress value. So we're effectively want to tell the tween, hey, you've got this function that we're visualizing here. Oops, there we go. You've got this function that we're visualizing here in the cheat sheet. We have progress from 0 to 1, which would be our duration in the interpolate property signature. When we get to say this value here, we want to get the y value that matches. So to do that, we'll just simply tell the tween to seek, and that says seek to some value within your duration. Since we know the duration is only 1 and we know the progress is from 0 to 1, then we can just seek to the progress value. And then that means that our tween has now set the draw position for this property to be our target y. So we've run our function. We kind of have the x and y coordinates we need. Now we just need to draw something. So to draw something, we're going to use some built-in image logic. Images is just a class in Godot, but for the sake of time, I recommend you play around with images yourself and read the documentation. But for right now, we're just going to work with an image. So image, to create one, is very simple. We will just create a new, let's create it up here, a private, let's call it a, let me check my notes. Yeah, let's say that, let me give a bit more details on how this is going to work. So we have our canvas here, and we don't want, every time you call update, it will wipe the canvas. Now, if we want to actually draw these lines over time, then if the canvas gets wiped, then all we would notice is for every frame, we're using the blue dot here, we would just see some dot move along, but we wouldn't see its trail. So we want to keep all of the previously drawn areas every frame, so that a way we can hold on to the trail for later and draw this continuous line, as opposed to just the discrete points as we iterate over the progress. So we're going to have to keep track of whatever the previous image was so that we can draw the previous image plus the new dot that represents the new position. So we want to make a, we'll call it private image texture. That gives us the texture that we can mess with. and we'll just call it image texture and just initialize it to a new image texture. So we have a blank image to start. And when we are ready, we want to create this image texture to match the size of our whole picture. So in our ready, wait, what did I call this? Oh no, sorry. Image, I misspoke. We'll get back to the image texture later. What we really want is just a regular image. Where did I go? So we'll call it private image. We'll just call it image. And this is going to be the image, which is the bytes that represent the colors that we're going to be drawing. And we'll just leave it as null. So when the node is entered, actually let's just say every time we draw, if the image, so if image is null, so if we don't have anything, then we want to initialize our first image. And we can just take the bounds of this control. So if we look here in the rectangle, we can see it has a size. We could hard code this, but just because the size might change depending on what other things we put into the scene, we can simply create our image based on the size of that rectangle. So to do that, we'll just make a new image. So image equals new image, just like that. And then we can say image.create, and that will create a new image. We can give it the width and the height. Since we happen to know our rect size, we can give it the x, which is the width, rect size dot y, which is the height. And then those both happen to be floating point numbers. So let's typecast them as int, since the create function takes integers. We don't care for maps, so we'll just use false. Oops. And then finally, the format. That's the format of the bytes. We're just going to use RGBA8, which means we have red, green, blue channels, as well as an alpha channel, and they each take 8 bits, so there'll be 4 bytes for data. So this will create a completely empty image that has 4 bytes per pixel, and it has X by Y pixels. And that's it. So now we have a basic image here that's empty for us to use. And we only do this if it happened to have not been created before, and it's the size of our control. So once we have this, we need to sort of draw a dot at the position that the tween has set the draw position to. Now, we could go through and modify the dot by hand. In fact, we can probably do that. So if we know the X and Y and we have our image, then let's just set the pixel for the image. So we can do image.lock. This locks our image, so we can edit it. You can read more details in the documentation. But basically, if you read and write when it's not locked, then we'll get into trouble. So we'll lock the image, and then we know which pixel we want to set. So we can do image.setPixel. We know the X, that is progress times the width. So if we know the progress goes from 0 to 1, because we normalized it here, and we know the width happens to be the rect size of the image, then we can just do, let's make a variable for it, pixel X equals image.width times progress. So if the width is 100 pixels, we multiply it by the progress, and that'll give us the X position. We do var pixel Y, which same thing, image.height times the draw position. So the draw position goes from 0 to 1, so we have it normalized currently, and we would want to just adjust it to the actual height. So very simply, we can times this by draw position, and now we have a X and Y coordinate. So we can draw it at pixel X, pixel Y, and then we can set the color. So for right now, let's just do colors dot beige, give kind of a white color. And here we can see we're getting an error because these are floats instead of integers. So let's just typecast them. Let's do it this way. And int. So now we have the x and y as integers. Int. No, I don't want that. I need to do some parentheses. Okay. So we have the x and the y. They are just integers, which we can use. Let's move these back to bars, which we can use to set this particular pixel. So now we've set the pixel that we wanted as beige, and then we can image.unlock, which allows us to start reading data from the image. So we've ran our tween to get our x and y coordinates. If we didn't have an image to start with, we'd create a new one. Then we get the x and y that we want to draw, and we're just going to draw a white dot at that position. And now our image has the picture that we want to show. So the last thing we need to do is actually render this image to the control. We haven't actually drawn anything to our canvas item, but luckily the canvas item has a way for us to draw an image texture, which is what we created here. And the image texture has a way to give it the data from the image. So to do that is pretty simple. We can just go to image texture dot, and then we'll give it the create from image that says create it from an image object. We happen to have an image right here. Give it the image, and that's all we need to give it as the parameters. And then we can just call draw texture, which says this control node, draw some texture, which is going to be the image texture. Now that we have the image texture, we can draw it at some position. We'll just draw it at the top left corner because it's going to draw the whole image. So we give it vector 2.0 that just says start at the top left so it can draw the rest of the picture. So if our image is this square, then if we just draw it starting from the top left, it'll draw this whole area there. And then finally, we can give it what color to draw as. Right now, we're not going to give it any sort of a color modulation. We're just going to draw whatever picture is in the image. So we'll hold on to that for a second. So we have our basic way to modify this guy. We don't actually currently have anything that messes with progress, but we can mess with it in the editor. So let's go back to the editor. Let's run our scene. It's going to rebuild. And while this is running, we can go to the remote tab here. We can go to our Tween visualizer. So here's the various properties of our live game. And the one we're going to mess with here is the progress. So let's increase the progress a bit. And that should call the draw function. Let me set this up here. And let's say we set it to, nope, we're not getting anything. Okay. Let's make it bigger. It might be just too small to notice. Let's do a print here. gd.print, and we'll just print something that's like here. So that way we can just make sure we're getting to our draw function. So we should be hitting this update, which should be calling draw. But let's just make sure that's happening. So let's rerun our scene. Go to the remote, mess with the properties of our object, and it says it's here. So we're getting something. I think the issue might just be that our image is drawing just a single pixel, which might be just a little too small, or the issue might be that our integer cast here is getting messed up. So maybe we can do this. gd.print. I'm doing this off screen. So these integers might be just some value that doesn't make any sense. So let's just do pixel x and see if the x is changing with the progress. So we'll rerun the solution. We'll go to the remote. We'll mess with progress. And we are getting an x coordinate change. So that's good. there. I just think that we might be drawing too small of a pixel. Set it to 50% and see. Oh, hey, we got a pixel right there. So let's, hey, you see this? So, yeah, so, okay, so I see what was happening. We're drawing our image from the top, our pixel Y is starting from the top left, and it's going to find its way down to the bottom right. So if we bring this up, and it's going very slowly, but we are drawing a line here. It's just instead of starting from the bottom left like we wanted in our example, it's starting from the top left. So that's easy enough to do. What we're going to do to fix that is when we're getting our Y, here we're starting from the top left and going down, but we want to start from the bottom left and go up. Well, we can worry about that later, actually. It's okay for these to be upside down, so you can just think of us as we flip these from top left to bottom right, but we'll worry about that in a second. But either way, we can see that we are drawing our picture and we kind of have a basic visualizer. Now, the one thing that was missing was we aren't animating it. We had to sort of mess with it by hand. So let's add that as our next little feature. So to do that, we're going to make another node or another scene. Let's make a new scene, user interface, and it's just going to be called Tween Player. And the Tween Player, we'll leave it pretty simply. Tween Player will have a Tween visualizer as a child, which we can set up however we want and draw the picture however we want. But we're also going to give it its own tween here, and we'll call this, well, this will just be the playback tween. But basically we want to be able to have this tween run automatically, and the value that it produces should affect the tween, the progress value that's being drawn here. So because we have a tween and we want to be able to configure this tween, we're going to add another Tween Player scene, and we're going to give it its own script, Tween Player. And we're going to do the same thing. Because we have a tween here, we want to be able to give it the transition type and the easing type. So we can just copy those two exports here, two exports there. And when we rebuild, we'll have a way to modify those. But since it also has a tween, let's copy the code from our previous script to get the tween. Here we go. Oops, got those backwards. Okay, so we've got our Tween Player, and when it plays, we want it to be able to animate our tween with this. So we grab the tween here, and so we can just very simply, well, let's also get our tween visualizer. So let's do private tween visualizer, call it tween visualizer. And same thing, when the scene gets initialized, we'll grab the tween visualizer node. Oops. Tween visualizer. And so now we have a tween that we can use to animate a property, and we have the tween visualizer. So we can just simply tell our tween to interpolate property on the tween visualizer, give it the progress property, and we can just simply have it run with, we want to go from 0 to 1. Let's have it take 3 seconds. We can mess with these later. And we want it to use the transition type that was previously set and the easing type that was previously set as well. So we're going to be able to control both the tween that we're drawing as well as the rate that we're drawing it. Just for simplicity, we're going to use linear as our default tween type. And so that's just going to draw a straight line, which will give us the most clear drawing of the particular setup that we've got. But later, it might be fun to try drawing an elastic tween with a exponential curve. So we'll get kind of some weird drawing animations there, but those aren't completely necessary. So we've got the transition type, the easing type, and we don't need a delay. So we have our tween here. We will set the tween to repeat. So that way, once it's done, it'll start back at the start. And then we'll just tell the tween to start its tweens. So when we hit play on this new scene, it will find the tween in the tween visualizer. It will use whatever the tween visualizer has been pre-configured to, and then it'll animate the progress for us. So let's try that. We've got the tween player. It's got its tween visualizer and everything. Let's run. And we can see the line is drawing. It's going a little slow. I think, oh, I know why. When we configured the progress, we said we wanted to go from 0 to 100, just so we can think of it as going from 0 to 100%. And let's also get rid of this print statement. We don't need that. And we can also get rid of this print statement. We don't need that. So we now have a way to animate the visualization for this particular tween. Not perfect. It doesn't match what we were aiming for exactly, but this looks pretty good for the short time we've given it. But we are only drawing a single, we've got a single transition type, but only a single easing type, and it's always in white. So let's add the way for us to draw multiple easing types. So the first thing is, for each drawer, we wanted to be able to give it a color. So let's do that first. Let's go export public, and we'll give it a color, and we'll call it color. Give it a get and a set. And let's just start with color dot. We'll use beige just for fun. But in here, in our tween player, let's rebuild, and let's give it a different color just so that we can see that, or so we can prove that the color has changed. So let's say we give it a, I don't know, kind of a light bluish color. Now we need to actually use this color when we draw our dot. So here we are setting the pixel to color.beige. We can instead set the picture to the color that was set in the editor. And now when we go to play our tween player again, we should see it drawn as, well, still beige for now. There we go. But, well, sorry, it's this color here because we set it manually. In fact, I think if we change it to beige, then now you can see the next line is drawing this beige. So we can update the color to get whatever color drawn. Maybe let's go for red. And we come back and you can see now it's drawing it as red lines. Normally we wouldn't be changing the color of the same line as it's playing, but here we can see it's working just fine. So we've now got a way to draw a specific color. Now that we have a way to draw a specific color, what we should do now is set up our tween player to create multiple tween visualizers. Once we have a, let's say the tween, or let me take a step back. Let's make an intermediary scene that takes a single tween transition type, but puts all 4 easing types into it. So we'll make a new scene, we'll make it a user interface, and we'll call this a multi-tween player. And the multi-tween player, we'll give it a script. Well, let's save it first. Give it a script, C#. And we want the multi-tween player, when it's created, to create all 4 of those tween players, and then give them all the same progress value. So to give them all the same progress value, we'll do sort of what we did before, which is we'll give it its own progress property. In fact, we probably don't even need to use the privately backed one. We'll just give it a progress property. And when you get it, it'll just get, well, there shouldn't be any way for you, reason that you want to ask it for the progress. But when you set the progress, we want it to set the progress value of all of the children. So to do that, we can just get rid of this code here. And let's make a private field. So private, we'll call it a list of tween visualizers. We'll call it visualizers. And we'll just make it a new list so it's always there. And when we have these visualizers, we can just do a loop over each of them. So for each visualizer in the visualizers, and we will set the Tween visualizers progress to be the value that just got set for our progress. So now when we set the value for one, or for the parent scene, it'll propagate that value down to all the children. And we have these visualizers here. So the visualizers list is currently empty because we haven't made any visualizers. So what we want to do is get the scene that the visualizer came from. So we have the scene saved as tweenplayer.cs or tweenplayer.tscn. So let's get that path. We can copy the path. We can go back to writer. And now we want to, when the scene is first created, we want to preload that child scene so we can instance multiple copies of it. So private read only, we'll make it read only because it shouldn't really, the scene shouldn't be reloaded or anything. And it's going to be a packed scene, which is just the type for a scene that's been saved as a TSCN. And we'll call it visualizer scene. And to load the scene, we're going to use the resource loader. And we're just going to load that path to the scene. So it was just in the resources folder, tween visualizer.cs. And when you call the resource loader, .load, it's going to load it as just some arbitrary object. But here we're going to get a problem where it says, I don't know how to change a resource to a packed scene. Since we know it's going to be a packed scene, we can just typecast it as a packed scene. And so now we have our visualizer scene. So that's great. We have the scene that we need to initialize. We want to create 4 versions of the scene, one for each of the transition types. So we can do that in our ready function. So in the ready function, we will just go over, in fact, let's just we'll make a function called reset. Oops, let's make it first. So we'll call public void reset. And just so that we have the helper function in case we need to use it later. When we call reset, the thing we want to do is add all of the visual, or if there aren't any visualizers, we want to make new ones. So if visualizers.count equals 0, then we need to make some in the first place. To do that, we're just going to instantiate the visualizer scene once for each easing type, and then add those scenes to the tree. However, we want all of those scenes to have the same transition type, so we need to now have a given transition type that will apply to all of them. So we'll just copy this again. We'll export the transition type for all of them, and when we go to create them, we'll just create each of them with a particular transition type. Now the easing types, each easing type we want to have a unique color, and we also only know there's going to be 4 easing types. We could try to get fancy, but since we know there's going to be 4 easing types and we kind of know what colors we want them to be, we can go ahead and just hard code that. So let's make a private read-only list of, let's make it a dictionary. And the dictionary we can give keys and values to. And so for each key, let's just make it one of the tween.easing types. And we also know that we want a color for each of them. So we can just give it a color as the value. So for each easing type, it will have an associated color with it. And we'll just call it easing colors. And we'll make it a new dictionary. Now, we can actually instantiate the dictionary with some values. So if we know the values, we can give it the key value pair. We know that the tween had easeType.in. And looking at our example, we know that in is green, out is kind of an orange, in out is blue, and out in is pink. So I'm just going to use those as my guide. For ease in, we'll go colors.green. There we go. And then we'll do the next easing type. So tween.easeType.out. That was sort of an orange. So we'll do orange. Then we had tween.easeType.inOut. That one was blue, we'll call it, or maybe more purplish. So we'll do colors.purple. And then finally we had tween.easeType.outIn. And that one will give it the color of pink. These colors are arbitrary. You can pick whatever you like, but we'll go with pink. And so now we have a easing colors map that goes from a particular ease type to the color we want. And we already know the transition type, so we can create tween visualizers with these easing types, or with the transition type, one for each easing type, which will just be the keys here. So let's do that. If we don't have any visualizers yet, we'll want to go over each of the possible easing types as well as their color. So we can do for each in the easing colors, we can give it the easing color here. And this is a key value pair. And if we know the key is the easing type, and we know that the value is going to be the desired color, then we can create a new drawing node for those. So we'll call it a var visualizer equals, we have that packed scene, so we can call it, get the visualizer scene, we can call instance on it. That creates a new scene, and we'll just typecast it as a tween visualizer for us. So we have the node. We can then set up the node, but first let's just add it to our, to our current self. So we can do add child, the visualizer. So this puts the child in the tree. And then we know the visualizer, we want the tween, or the transition type, to be our transition type. Where to go? Right there. We know that we want the visualizer's color to be the easing color key value pair. We want it to be the value because that's its color. And then we know the visualizer dot easing type. We want that to be the easing type, which is the easing color here dot key. Oops. So our visualizer has been set up with a particular transition type, color, and easing type, which are the ones that we want. Okay, so now when we run the scene, the first thing it'll do is call reset. Reset will add all of these visualizers, and we can then push the progress value to each of them. So let's go back to our editor. First thing we want to do is we'll go all the way back to the tween player. So instead of it having just a single tween visualizer, we'll delete this. And instead we'll give it the multi-tween player. Here we go. And then when this updates, whoops, instead of it, the tween player looking for a tween visualizer, it'll instead look for a multi-tween player. There we go. And then the multi-tween player will look for a child node called multi-tween player, and we'll cast it as the multi-tween player. And then finally, we'll have the tween interpolate that. So the multi-tween player will get a new progress. That multi-tween player will then propagate the progress to all of the child tween visualizers, which each have their own easing type, color, and they all have the same transition type. That's the same as the multi-tween player. So let's give it a shot. Oh, we got an error. What did we get? Oh, cannot export a property without a getter. That's very simple. So when we created an export property in the multi-tween player, we didn't give progress a getter because we have no need for it. So we're just going to make a dummy getter for it, and it'll just always return 0. There's no need for us to return the progress yet. We could maybe look at one of the visualizers here and set the progress, or and read the progress that it's got. In fact, maybe we can do that. We can do visualizers first or default. The first default will be, oh no, we'll just return 0. We don't want to get tricky. So there will never be a reason to get the progress property, so we'll just leave it at that. Let's go back to our editor. Let's run the tween player. And I think we were getting a null reference exception. And so in the multi-tween player, when we hit reset on line 47, we're running into a problem here, and that's because the visualizer scene is apparently failing to load this, and that's because we loaded tweenvisualizer.cs. We need to do tscn. That gives us the actual pack scene. I did the CS script on accident, which wasn't useful for that. Okay, so we've got our tween player, but we're not seeing anything quite yet. So let's take a look. Let's first double check that the multi-tween player is actually adding the child tweens. So let's go to the remote. We have our tween player, we have our multi-tween player, and it has the 4 visualizers. You see they each have their own color, but they aren't getting any progress. So I think what might be happening is this tween player here, oh, well, maybe I saw the wrong thing. Let's make this smaller and draw multi-tween player progress. For some reason it's not cooperating. Let's go back and look at my notes. Okay, let's go back and actually get this getter. I wonder if the editor is having trouble with this getter here. What we'll do is we'll just get child. So we'll get any of the children that are currently added. We'll get the 0th child, which should be a tween visualizer. And then we'll just cast that as a tween visualizer. And once we have the tween visualizer, we'll tell it to return its progress. Oops. And so that way, at least we have the first tween visualizer's progress. Hopefully that'll make the editor cooperate with us. And in fact, I'm going to set the tween player as the root scene, so that way I can just hit play. Okay, so while that's running, I'm going to take a look here at the tween player. Messing with the progress, but these guys aren't getting progress. If I set these manually and draw them, yeah. So if I mess with these myself, we can see it's drawing. So the tween player, when I get the progress, it's not properly updating the progress. So I'm going to set a breakpoint here, and I'm going to debug it and take a look. Okay, so the visualizers is currently empty, and I know why. I forgot to actually add it to the list of visualizers when we're done. So I can do visualizers.add the visualizer. So we were never actually tracking it. I could have instead done get all the children and go over them, but let's just hold on to it directly. So that way we have a list that we can iterate over instead of trying to iterate over arbitrary nodes, just in case there happens to be another node. And hey, look at this. We're drawing all 4 of our easing types, and we've got 4 different colors, and they got the 4 different curves. So what we can even do is go to the remote here, and let's just mess with maybe this one and give it a different transition type. And now you can see how green is drawing on a different line. So if we mess with the transition type, it updates the colors there. So we now have a way to draw a single one of these, whichever one you have configured, and it'll draw it onto the screen. So look at that. We've got a visualizer for these. Now, I think that's it for part 1. This has already gone on long enough. What we're going to do for part 2 is actually work on implementing the rest of our controls here. We have a window here to draw a single one, and it goes over and it draws a tween a step at a time at some color with various easing types. But we want to add a couple new features, which are changing the transition type so that way we draw different lines, options to enable and disable the various easing types so that way we have a selection of colors that we want. And then also we want to be able to mess with the playback so that way the speed that it comes back, we can control that with the easing in and easing out. And I also want to add one more thing, which is currently we're just drawing these lines as solid lines, but once they've drawn a few times, you can't really visualize what's going on. What would be cool to do instead is have the lines fade away. Maybe we'll have a checkbox as the option there. And the lines will fade away, and so when you go ahead and enable the fade feature, you'll see the lines kind of get drawn, and then the tails will fade away, so that way you can see it draw on the next iteration. So with that, hopefully this has been useful, and hopefully you learned a thing or two about drawing tweens and how to draw things with a canvas, at least at a basic level. And I'll see you next time. But before we go, let's make sure that you, if you want to see something else or if you have any ideas, leave a comment. And if you want to see the channel grow, feel free to share this or subscribe or do whatever you can to get the word out. So thanks for watching.